I'm going to very briefly introduce our product as we go through. But one of the things that's been core to us ever since we started in 2012 has been the concept of digital thread, which means maybe not so much to some of you, but it certainly is familiar as a term because it's been on the top of the hype cycle for quite some time. And what was interesting to me as we started in this journey is that the idea of the digital thread actually comes from obviously military applications and from the Second World War. And many of you will be familiar with the concept that in the Second World War that planes coming home were analyzed as to their the impact of enemy fire. And it was then thought that, well, the planes are vulnerable in the areas where fire hit them. But actually, obviously, that was not the case. Abraham Wald found out that it's actually the areas that were not covered where the plane was most vulnerable, because that's the planes that never came home. So really what we want to find out is how does a plane behave throughout its entire life cycle? Not only at one fixed point in time, as in the digital twin, so to speak, of that plane at that time, but how does the data, or what happens to the plane throughout its life cycle? And that's the concept of the digital thread also applied to additive. We don't only want to find out what happened to the part in the printing stages, although previous speakers and especially Sigma Labs have spoken to that very eloquently. It's a key problem. But we want to find out what is happening to the part throughout its entire life cycle. And that's really a data problem, and it's not a big data problem as such. We have been inundated with this idea that big data must be captured, and we need big data from everywhere. Actually, I think of this as a relatively narrow data problem, because what we're lacking here is contextual data that ties the part history together from the beginning of the process, even in the design stages, to the shipment. And so obviously I've simplified the process here massively. There's many more stages here, but what I wanted to make clear is that there's various different data pieces, whether they're manual data capture, actual digital machine data, whether they're from sensors or third-party sensors or OEM data, and obviously the inputs that go into the process as well. So lots of different types of data that need to be captured, but we're not going to be able to start capturing that data in any meaningful way unless we know why we're capturing that data. And so the two elements that we think are important are firstly efficiency, and then secondly the knowledge element. And I'll get into those today. So really what I want to talk about today is what is it that we're capturing, what does Authentise capture in the digital thread, and what is there to capture, and what can we glean from that data today, and what can we potentially glean from that data tomorrow. But before I do that, I have to tell you a little bit about what Authentise does, and I don't want to spend too long on a pitch of any kind. But essentially, the core product is a manufacturing execution system that manages the production of data all the way from the order entry to the shipment. That product has various features. You can take orders in, they are automatically quoted. You can view the orders in 2D or 3D. There's integrations in CAD. You can integrate or create and then manage workflows and work instructions and require feedback from the operator on the shop floor for the manual actions. You can schedule the object automatically or manually. It ties into your machine data, so we know what is printing, when it's printing, and the related sensor feedback. The maintenance management is managed through the system. There are automatic status updates, as I just referred to, but also manual status updates for the stages that are manual. We have a material traceability feature in the platform, so you can track the entire genealogy of the material before it hits the machine. And all of that data, the operator data, machine data, and inputs is all captured in a single traceability document, which of course that data can also be used in a variety of other ways, whether it's accessible via APIs or in analytics dashboard, or you can create your own analytics dashboards using Power Automate and other integrations. So that was a very, very brief jump over what Authentise does, and I'm very happy to go into details. I expect we won't have time for Q&A, but you can ping me directly. What I do want to kind of point out here is that this system already manages a variety of different data, either the data that's captured in the preparation of the file or the build of the file, or the data that's captured manually on the shop floor. And typically we distinguish the operator data on the shop floor is handled through an app, and the prep system features are handled through a computer. But obviously there's a third step here, which is not everything that is done in the process of getting a part to print and managing the production cycle will be done in Authentise. A lot of the time we're going to be using third-party components or third-party software as well. And so this is, at the moment in the digital thread, that tends to be a kind of black hole. We don't really know what's happening there. So Authentise has developed an approach to this, which starts really with the framework on which we built our technology, which is this modular framework. Most frequently, users never engage with this, but they are individually addressable via API if you want. We have each of these 30 or so modules are available. But what's important to point out is that it gives us a high degree of flexibility because these modules are connected to each other to produce the software that I've just demonstrated. But it also means you can connect other modules in and out. And B, we have a lot of third-party components that you can switch in and out. The ones that are marked in italic are third-party components. So these are actually components that you can move. In many cases, there are multiple third parties competing for the same functionality, so you can easily switch between those providers. So that's the framework that Authentise is built on. And that gives us the flexibility to start thinking about how can we integrate third-party behavior and really track what's going on, even if the features aren't or the functionality isn't present within Authentise proper. And one of the ways we're doing that is a new feature that's about to be launched, called pre-production workflows. So we already manage workflows for production steps, but this is for the setup of a part. We're organizing the process a bit better. Some of our aerospace clients, for example, want to have certain approval steps in, when orientation or design or material selection has been done, they want managers to sign off. So there's a manual component in that pre-production workflow. But obviously, this gives us the opportunity to integrate some of those modules that I just mentioned. And so one example is, for example, mesh healing. The idea that you can create a workflow template that is your own. And in that workflow template, you have one stage that's mesh healing. And instead of downloading the file, uploading it to a mesh healing software, CAD software, saving it, downloading, uploading it to the system again, you can now use an API to hit various mesh healing algorithms at any given moment and bring the results right back into Authentise. All of that is happening headlessly and replaces the 6 steps that you would have had to do manually before. So there's an efficiency gain, but there's also then the knowledge gain for the system in that we can track what actually happened in that process. This can be extended to a variety of other features. For example, even in discussions in some kind of hollowing aspects or lightweighting, could we potentially start integrating CAD features into that process? And in other areas as well, we have integrations that allow for additional quoting solutions. Authentise has its own algorithm, but third parties are also welcome on the platform, and here's a provider that's already integrated. Watermarking is the ability to add serial numbers into an object. That's already present in Authentise. And geometric search also allows you to search the platform for similar designs that were printed in the past. So various functions that are happening, typically happening outside of the system, now because they are headless and at API level can be brought into the system without any interface changes. Really exciting things that are happening, and that's an especially valuable process that's happening in the pre-production area. In the production area, things are a bit more involved because obviously we need to have integration with interfaces in order for users to start managing the production workflow. And I wanted to just highlight how we're trying to solve that problem. Again, the effort here is to track all available data, even those process steps that are not usually conducted within the Authentise software, or for which Authentise doesn't have its own solutions. And here we've integrated other providers in the production process, one of which is ADDIGURU, which tracks uses computer vision algorithms to detect potential build failure in powder bed systems. They are using Authentise to display, first of all, alert the user that an error may have taken place, and then display that error to the user in the Authentise system. The user still has the option to jump into ADDIGURU's own interface if required, but again, a lot of the understanding of what's happening and therefore the knowledge, the traceability of it is available to Authentise. Same is true for NebuMind, which is a platform that provides a digital twin. It maps the sensor data back onto the geometry that was printed. And that's available in Authentise now as well. And this exchange of data between the NebuMind algorithm and Authentise is seamless to the customer and replaces, again, multiple steps that are happening otherwise. So in short, in terms of operator actions, we already capture in-system and shop floor data, and we're in the process of capturing pre-production third-party software data, either through direct integrations in the pre-production phase or in the production phase integrations that have more interface involved with them. And where none of that is possible, we also have integrations that allow us to passport, i.e. get not only the build file, the model file back into the system, but also a passport of what happened to the model file during the process. So 3 approaches to capture the digital thread for even in process steps that are not happening in Authentise. And that's important for the user, because the more we focus on the operator and the flexibility and the efficiency to the operator gain, the more the operator uses the system and the more data we capture and the fuller the digital thread therefore is. Same is true. Same approach also counts for material genealogy. So the idea that materials change as the powders are blended is obvious to everybody on this call. But previously there may not have been sufficient tools to track that properly, especially in the context of what is being printed where. So there were separate tools available to track material genealogy. Authentise has now built that into a manufacturing execution system so that we can immediately tie genealogy to the actual print that's happening on the machine. And we do that using the handheld QR app, as well as QR labels that are then attached to the material containers. And then obviously the third component of data that is being utilized is the data that comes from devices. Authentise already integrates with more devices and more additive devices than anybody else, and uses that data for a variety of uses, which I kind of touched on earlier. But there are obviously growth opportunities for us as well in terms of non-additive devices that we're working to integrate, and then testing devices, then getting CT data, for example, directly into the system as well. But most interestingly, what is the value of capturing this data? Right now, the buzzwords in Industry 4.0, or the applications that were identified as the potentially most lucrative, are not really value add. They are not they don't have much return on investment. That's because predictive maintenance is essentially an expensive insurance product, and analytics is a colorful way to entertain managers. Right? Instead, we have to focus on the 2 elements that I mentioned earlier that really deliver value. One is efficiency, and the second is knowledge. And the way that we do that right now in Authentise is in efficiency gains. That's where the value really comes in. Within the first year, that's where you immediately see that value. Is, for example, in just automatically updating the order status based on what's happening in the machine. Right? That's very simple, very pragmatic, but it saves real money. And you can see that in the real data that's coming back from our clients. They're saving up to $100,000 a year just in knowing what is currently happening on the shop floor. So that transparency element really helps them. Boeing is a big customer of ours, as I alluded to. And within 8 months, they were able to save 80% of their order review time, 95% of their build setup time, and got a ROI of 300%. And on top of that, were able to do projects that they never were able to do before. So that's on the efficiency side, but also then on the knowledge side. And the knowledge side is interesting to us for various reasons. One particular project that we're pursuing with TWI at the moment is to understand much more about how materials impact final build quality. There's been a lot of exploration in terms of what type of material and potentially how the blending strategies work, but there are other elements of material degradation that haven't been properly explored. For example, the storage conditions, and digital thread information as such as what I've displayed today really can do that for you. The power of being able to do that is because Authentise is capturing for the first time ever the full context of the build file, as opposed to your PLM systems, which capture buckets of information, or even worse, the Industry 4.0 data lakes, which just slam the data from sensors directly into a bucket and don't contextualize it with the rest of the data. I'm running a bit over, so I'm going to wrap this up. But what I'm interested in is building on that concept of contextual data. And there are many value-added applications that can be built only on contextual data. For example, very low-hanging fruit is benchmarking. So the ability to just track what's happening to a part and compare that to what's in the shop floor, and compare that what's happening to other shop floors that are similarly aligned. You can't do that without context. Maybe more highbrow and high level is using data from the entire production system and feeding external algorithms such as intelligence to identify potentially other chemical mixes and other materials. And one project that Authentise is focusing on very specifically is the concept of supply chain. So very basically is what happens if you tie the contextual data from a supplier directly into a system that is managed by the buyer, so that the buyer can see within their own system the machines of the supplier as though they were their own, and see what happens in the production center, where their part is, how long it is still to be produced, are there any exceptions that are starting to happen in real time, that traceability, but also how much spare capacity do they have, and obviously a reassurance that their data is being handled securely. Many benefits to tying that data directly in, essentially automotive grade supply chain management at aerospace scale. So very exciting things that are happening there. Again, something that we're pursuing with TWI is just to understand how that adoption curve works, because we all know what is at the end of that process is getting all the data that you need to digitally, remotely, fully qualify a part. That would be fantastic. Right, that's the end goal. But what we really lack is an understanding of what are the micro steps and the additional value we can add on the path there, given that it's such a long horizon aim. We know how to get there. We know that it involves a lot of different third parties doing their best to analyze very specific elements of the production workflow and then aggregating that information for suppliers. But we don't yet know what the steps in that trajectory are. So, that I think is for me is a quick summary. Additive is a really good learning ground to make these experiments in, but the application of the learning that we're making in the industry goes way beyond additive, because the manufacturing, well, the global economy as a whole is becoming much more focused on that ability to deliver products at speed. We saw the challenges during the COVID crisis, and we need to be able to have a much more agile supply chain. Additive is that example of lot size 1, and if we can develop tools that work here and scale in additive, they will scale in other industries too. So important work here from everybody. Thank you for your time.
Brilliant, Andre. Thank you very much. Some very, very interesting stuff in there. One of the just time for one question maybe. In terms of the sort of the commercial sensitivities in this, I saw that you were looking at supply chain and involving OEMs, and there being sort of quite a direct relationship potentially between supply chain and OEM, and whether there was, whether that was something that everybody was okay with, that that they felt it was commercially good for them, or whether they felt that it was sort of Big Brother was watching them and would be trying to erode their margins. So could you give comment on that?
Yeah, that's an interesting question. So our initial findings from, obviously some of the OEMs are already clients and speaking to others as well, is that the OEMs would be willing to commit to offtake if the supplier is able to share data. Now, there's a mixture here of a technology solution, which is give the supplier the comfort that they have the tools to control exactly what data goes to the buyer. Right, that's number one. But there's also a commercial element to this, which is that the buyer is committing to a certain degree of offtake if that data becomes available. And so there are those two elements working together will solve this challenge. And again, additive is a great opportunity to solve that challenge because there's not as much legacy processes. There's not, we're not baked into a certain mode of working. So if we develop a way that works here, it can be more easily applied to other similar industries. So I'm quite excited about those experiments right now.
Okay. Brilliant. Thanks. We're going to have to leave it there.
Thank you.
Appreciate that. Thank you very much.